Right, and good morning, everyone. This is another Midfix podcast. With us today, we've got Dan Baker from Starflex, and obviously one of the subjects we want to talk about. It's a key topic in construction, something which is sometimes overlooked, should we say? And yet we're here to talk about thermal expansion. So welcome, Dan.
How you doing?
Yeah.
You all right?
Not too bad, mate. Nice to have you here. Bit different from a normal day's work, eh?
Definitely, yeah. Very strange, but yeah, excited to be here.
Good stuff. Right, mate, we'll just crack on then, I suppose. So obviously the main reason we do this is to talk about specific topics that are related to the industry. So, like you said, thermal expansion is a very critical part of that. So, I mean, to the average layman, how could you explain thermal expansion in a real, fairly short paragraph, just to... no pressure.
Yeah. Well,
no pressure. Pardon the pun.
Yeah, we'll get onto that. Thermal expansion, in layman's terms, is how a material reacts in a change of temperature. So when you heat a piece of steel, how far it grows over its length. So, for example, in our industry, you have steel pipe that will be in a low temperature water situation and will, once heated up over a 30 metre length, will expand 30 mil, for example. And that's how do we combat that in the industry? That's pretty much. That's how we do
it. It's controlling that movement. So you know how much it's going to move. So it's how we best control that.
That's it. If you do nothing, you don't know what's going to happen to that movement. So it could go all to one elbow, pop your pipe work, and then you've got leaks all over the place. So our job, or the way that I look at it is can we control it in the easiest possible way? And that's pretty much how we look at thermal expansion. Really, we look at a system, see how much it's growing by over its length, and then see what we can do to control that expansion within pipework mainly. Low temperature water systems, steam systems, and then every so often we have like chilled water systems, which are obviously over big long periods.
Yeah. So what's the biggest kind of pipe you'd kind of got to? Can it be any size?
Well, that's the thing about thermal expansion. It doesn't matter the size; it's more the material and temperature. Yeah. Okay. So 15 mil copper pipe will expand exactly the same as 150 mil copper pipe, or 300 mil steel will expand exactly the same as 15 mil steel will. So it's not so much the nominal ball. It's the temperature. And the pipe material. That's what dictates thermal expansion.
Sure. So, in regards to, I'm guessing there's a few ways of handling it. Some people call it a dark art.
Yeah.
So I know there are various ways to do it. There's more traditional methods. There's more ways of involving a bit more innovation. So are there like a set amount of ways to do it, or is there? There's
lots of ways to do it. Loads of different ways to do it. The easiest way we would probably say is natural flexibility, which is something that you want to try and do straight away because it's the easiest. The other way, obviously, is adding expansion bellows into this system. There's many types of expansion bellows. You've obviously come across them. The axial expansion bellows, lateral and angular are the three main expansion joints that you'll put into a system to control thermal movement within a system.
So can you do it without bellows?
Yeah. I mean, ideally you want a system without bellows and just certain anchor points, which are clamps that clamp down onto the pipe to anchor it, and then that then controls your movement from that point. Yep. And if you can get away without putting expansion bellows into a system, I'm sure the industry will agree it's the best way of doing it. Because expansion joints are, once you cut an expansion joint into a piece of pipe, it's then the weakest point in the system because it's a spring effectively.
Yes, absolutely.
Rather than a steel piece of pipe or
solid piece, basically.
Yeah, exactly. So it's always going to be the weakest point.
I didn't realise that. So really, then your first thing is to avoid. You look at avoiding putting in bellows, and you put bellows in. It's only if you really need to.
Yeah. I mean, 9 times out of 10, bellows are put in because of space constraint. You haven't got the space to put them.
Right. Okay.
So you would you can use loop systems, so changes in direction basically. If you've got the room to put a change in direction in within your pipework, then
is that what they call like a loop?
Yeah.
For example.
Yeah, that's it. Vertical loops or horizontal loops that have to be supported naturally. But if you can put loops in, then you don't have to put expansion joints in. The natural change in direction will not eradicate, they will absorb the thermal expansion. You don't ever get rid of thermal expansion. It's always be there. It's just a case of controlling it.
Yeah.
And that's the main thing. Then as soon as, like you said, as soon as you're putting a bellows into the system and then you're putting pressure within that bellows, then there's always a chance that if that bellows not installed correctly, not guided correctly, not anchored correctly, then that will be the first thing that will go. Or if it's not installed straight,
I was going to say it's only got to be slightly off, and then a bit of pressure is just going to.
Yeah, as soon as you pressurise a bellows, it's an unrestrained bellows, it's going to squirm and it's going to cause problems. And then I think expansion joints probably get a rough deal because that'll be the first thing that will go in the system. But it's 9 times out of 10, it's not the expansion joint that's the problem. It's many other things. The pipe's not straight over a long period of over its length, that kind of thing.
It's the installation.
9 times out of 10, well, we like to say it is anyway.
No, but it
normally it is, yeah, and there's little things can affect it. I mean, you put an expansion bellows in, and then you don't put the anchors in for say 2 or 3 weeks after, maybe because of delivery problems or whatever, and you haven't supported the pipework around the expansion joint, then that bellows will, can crush under the weight of the pipe move, move slightly, and then once you put the anchors in, pressurize it, it squirms, and it makes it look a lot worse than what it actually is, really.
Yeah. But it is. I mean, that's another topic we talk a lot about. Is we use tried and tested products, like you would with your bellows and your anchors and guides.
Yeah.
But we find the only thing we can't control, which is out of our control, is the installation.
Yeah.
So we can do the load checks, we can do the drawings, we can spec the anchors, you can do your thermal expansion design. On paper it works, but one thing you can't control is the install, and I think that's where we're really pushing this, the academy side of it, because honestly, there's no real proper structure with training. There's no kind of, there's no real due diligence that's done, and I think that's, I think we notice in the industry that kind of thing's been talked about more and more because it's the last thing that had to go wrong. Right, we've got the right products, it's all tested, CE marked or whatever. Oh, but now we need to make sure that they, not saying they can't do it, but what bit of paperwork, have you got anything to show that, he's done this course or whatever?
I agree. I mean, I've done college courses from like being an apprentice to like just finished my degree in building services, and not once have I ever been shown how to fit an expansion joint, how to fit a piece of pipe.
Exactly.
And I've wrote, numerous reports on it, done lots of assignments on it, done calculations on, pipe sizing and things like that, but not once has, have we ever gone to a workshop or anything and actually put an expansion joint in a piece of pipe, or fitted an anchor or a support or a bracket or anything. That's all. It's
crazy, and
then
that's so critical as well.
Yeah, There's nothing that never gets looked at. And then on the flip side to that, you'll have contractors, and you'll have the same as well, Jake, ringing you up, who've probably been on site longer than what me and you have been alive, asking, how do I fit this? Where do I fit this? What do I do with this? And you're thinking,
and the brackets are already installed. You're like,
yeah, exactly. Like, you want me to move that? It's not as easy as that. I'm like, well, yeah, I need you to, because it's wrong. And they're just looking at you saying, well, why should I take advice off yourself? And I'm like, well, because it is that is what you have to do. It is a tried and tested way.
That's the way it's got to be done. There's no ways around it, unfortunately. But that moves on to the next point. Really, is when you should be involved. Obviously, with us, the earlier the better. The sooner we're talking about specifying products and designs, the sooner we can get speaking to them, the better. You've got more time to plan. You've got more time to iron out any issues or potential problems. So is it the same with expansion?
We always find that if the consultant is specifying, it all leads back to the consultant. I don't know whether it's the same with yourself, but like if the consultant is specifying expansion bellows on the system, then it creates the conversation. It creates the dialogue between us and the contractor or the supplier or whoever's fitting it or whoever's in control of that design. 9 times out of 10, there's just a minimal line in the spec that says expansion needs to be looked at by a specialist to the contractors. Contractors, like, he has to take on that responsibility. And then if the contractor has to take on the responsibility, then he will look at it at the very latest stage possible.
Yeah.
But if there's actually expansion joints specified on the drawing, even if they're just indicative positions, it makes the contractor say, well, I have to put something in. I have to look at this.
Yeah, sure.
And that, we always find that it works a lot better that way, because then when they're locking in their prices for the design, they're putting their tenders in, they are getting a cost
for the bellows as well, which would cover
everything. Yeah, exactly. So
Yeah,
then
okay.
when we come to look at it a bit more concrete, we can say, okay, well,
you don't actually need bellows on this.
Yeah, on the design, there's probably 10 bellows. We can't get away from putting a bellows in this line, but if you anchor here and anchor here, job.
Yeah. So there's
Job's
enough
done.
money in the pot, basically, as long as so basically the idea is to get bellows on the original drawings.
And it can
So then there's
only
enough
get better.
money,
It can only get better.
Okay,
Exactly.
yeah.
The design can only get more beneficial to the contractor. Then it can only benefit them. The fact that they're already costing a bellows. They're already looking at, okay, well, I'm going to have to cut in a bellows here. Might even have to create a stall piece to come back to that. They're already thinking about that cost process, not at a later date thinking, I can't afford to do that.
Sure.
Or coming to us and they're on site and then it's a bespoke item, which we've had that, and it's a bellows that's never been made before, at a specific length, a specific pressure, temperature, and they expect it on site, yesterday, and you're just like, it just can't happen.
Yeah. No, definitely. Okay, so I'm guessing it's more consultancy led with. That would get them before it goes out to tender.
Yeah, we find that it's a lot easier if they already know they have to look at expansion within the system. They have to look at the thermal growth within a system, both on chilled and on like the low temperature system specifically. Like I said, it creates that conversation. They already know that they have to,
Yeah.
look
They
at
should
it.
be anyway.
They should be anyway.
But
Yeah.
it's a bit. It flags it up, doesn't it?
If the contractor, especially on smaller jobs, I think smaller jobs is a lot less recognised. On, I don't know, all due respect to maybe just a care home, and it's a one-man band, M&E pipe fitter and his mate kind of thing that have picked up the job, and they're just banging it all in copper or plastic, and they've never really come across it before until that one time they do, and they're like, how do I deal with this kind of thing? And that's when you get called to site and it's already in. They've already turned it on, and you turn the pressure and the heat on, and there's problems. I think on the bigger jobs where there's big risers and there's big loads and the stuff that, if that goes wrong with the pressures that we're talking and the loads that the anchors are potentially being under, there's a lot more that can go wrong.
Yeah.
If there's these a little smaller care home, if some 15mm copper pipe pops or something,
it's not the end of the world.
It's not the end of the world in the grand
yeah.
scheme of things.
And that's how it's looked at, unfortunately. Is it like,
Yeah,
okay,
it is.
I should consider it, but if it goes wrong, what's the worst that can happen?
Yeah.
Might be a couple of grand's worth of damage or something.
Yeah, exactly. And if they turn it on and as soon as they turn the heat on and they get it tested, or they test it, turn the heat on, that's it then. And there's no leaks. Job done.
Done. Yeah.
Move away. That doesn't mean that
Won't leak again.
there's
Yeah.
about 4 or 5 branches that are overstrained and will go quite soon. Once when the heating's going on and off. So yeah, it's definitely something that, like you said, earlier the better. But really, in the consultants package, they want to be putting at the very minimum, putting indicative anchor points on. Indicative anchor points and expansion bellows on the drawing, so at least then the contractor knows he has to look at it. But then, in the same point, we're saying this now, but if a consultant come onto us and we did a full expansion joint, expansion design, either with joints managed to say, well, you can natural flex here, loops, take your expansion out on your corners just with some clever anchoring, then we could do all that.
You could actually quote it accurately.
But then they could then just say, then consultants will say in the spec that they won't specify my company, Stourflex. They won't specify. They'll just say C expert, but the design's been done by myself.
Yes, yeah.
And they can just then farm that round. So then, as much as I'm saying the earlier the better, let's look at thermal expansion and eradicate the problem. But then that would create a lot of work for people like myself, my competitors and my bosses and stuff, because we'd be doing all these fantastic designs and not getting no credit for. Because that's, and we don't get paid for our design services, even though we're taking full responsibility for the design of.
It's like the sprat to catch the mackerel, isn't it? It's kind of. I understand. I suppose it's because you're only marking up the drawings to start with.
Yeah.
It's not like, we'll produce, when we're doing a frame, like a official drawing with midfix all over it. It's a bit different with that, because if someone decides to go elsewhere for a design, well, obviously our design is void. You know what I mean? It's not valid. So that ties us in. But I can imagine with marking up drawings, it's a lot easier to, if you like, farm out. But
yeah, definitely.
I suppose it's all part of that.
As soon as we send that quote and we send that design out to them, we are then quite vulnerable, because they can come back to us and say, we want 10-15% off because your competitors come in and just, he's looked at the drawings, and I've been guilty of it. I've seen competitors' drawings and said, okay, I can match that, or I agree with it, or I don't agree with it, but we can match it. And so that there is a fine line of, as soon as you put that your design out there, it's there to be farmed. It's there to be farmed out. So I think the only real safety net that you've got is you don't give your calculations.
Yeah, sure. Yeah, you always keep that. You've got to keep that back anyway.
You have to say, look, yes, you've had my design, you've had my quote. Don't. You're not having my calculation to prove that my design works. If you're going with someone else, then they have to prove that it works.
Yeah, but I think that kind of thing, it's got to stop. I suppose it's not fair, and two, it's dangerous. If someone's done the design and then you're going out, why would you risk it? And I think that's the kind of thing which we're trying to do, is kind of make the industry safer. There needs to be more regulations, more of like a checklist on certain things on jobs. I mean, so with that in mind, what's your biggest bugbear with the industry's attitude to expansion, and what would you advise if you could give someone advice expansion to help them further down the line in the project? What would make it a lot easier for you guys and them, I suppose?
Good. What was the first bit of the question again? Sorry, was
I forgot now. The first bit was
biggest bugbear.
The biggest bugbear, Cheers, Scott.
Biggest bugbear is obviously that them not accepting, the contractors not accepting that the expansion is an important issue until it goes wrong, and then until you get the phone call to say what's wrong with this. That's the biggest bugbear. The second, there's two biggest bugbears as well. That when a bellows squirms, it's automatically our fault. That's probably one that.
It's the same when our fixings pull out. It's the fixings' fault.
Yeah, it's not. Nine times out of 10, it's not. Yes, okay, on the one occasion there might be a faulty bellows, of course it is, but that's the biggest thing. You'll get a phone call at 5 o'clock on a Thursday night, and they want you on site the next day. You know that you have to play the game, obviously, but you know that it's not going to be your bellows that's the problem. It's going to be, okay, well, have you fitted the anchors? Well, let me go and have a look 10-15 meters down the run. No, we haven't fitted them. That'll be why. That's my biggest bugbear, that when the bellows squirms, because they look ugly when they squirm, and it does look, because like I mentioned before, they're the weakest point in the system, so they're gonna go. When there's a problem in the system, they're gonna go.
That's the first thing to go.
That's the first thing that goes. You get the phone call to say something wrong with your bellows. There's nothing wrong with their system. The way they've bracketed it, the way they've anchored it, the way they've guided it. There's nothing wrong with that. All the pipe work changes.
So I suppose the best advice is, don't try and cut corners and save money in the first instance. If you like, do it properly. If you like, it's a bit of insurance, isn't it? No one uses insurance, but you pay for it on the basis that if you do need it, it's there. And I think that's a bit like thermal expansion. it should just be allowed for cost-wise, and
Yeah.
allow it, do a proper job, because, like you said, normally nothing goes wrong, but when it does, they call you out and then they moan at the cost. It's like, well, if you put it in the first place, it wouldn't be as bad.
Yeah, 100%.
But you can apply that to a lot of the industry, even with brackets and things like that.
Do you think communication's quite a big thing in the industry as well? I mean, in terms of
massively,
we will do designs, markup drawings like yourself, and then it'll be ordered, and you think, great, got the order, we've delivered it. Everything from our point of view is absolutely fine, and then all your kit will get to site, and it'll be like, there's a piece of cable tray ducked in.
Yeah.
There's a column that's appeared out of nowhere that we have to go around. Does that affect the design? Yeah, it does. If there's a change in the pipework run out of nowhere, it can affect the design massively. So
but that's it. It's kind of we have the same with that. It's out of our control. We can only work on the info we're given.
Yeah.
If it's wrong, it's like, what chance do we have?
Yeah. But it's still your fault though, isn't it?
It's still your fault. But the other thing that is construction. Is it things change at the 11th hour? I don't think it will improve, but I think that's just the nature of the beast. It's it's construction, isn't it? And it's how you react to these changes, I suppose.
Yeah, it's a fast-paced environment on site. When you're walking around, there's things going on left, right, and centre, isn't there? So you can understand the quick changes that happen.
Yeah, but like I said, communication is definitely key.
Yeah.
And I suppose as well, from our point of view as suppliers, like you said, you can put forward a solution in that, and you've got to be because these guys are busy. They've got 1,000,001 things to do.
Of course.
All you're doing is expansion, so you need to make sure you need to keep on to them and reminding them, and because like I said, if you're, and I suppose they're expecting you to do that as well, because if you don't, they'll go 3 weeks and you won't hear from them necessarily.
Yeah.
You got to keep. So I think from a communication point of view, we can help drive that.
Yeah, that's a good point.
Do you know what I mean? Because I find you can't just quote and sit back and
no.
And I find that actually they're like, no, you need to push us to keep it moving, because they can't remember everything.
Yeah, you find that people on site, they deal with what's in front of them.
Definitely.
So if you're in front of them, they'll deal with you. If not, they'll deal with something else, whatever else is going wrong or right at that point in time.
Yeah.
Yeah, no, 100%. That's a good point. I think with like thermal expansion, it's always going to be there. You're never going to, as soon as you
science.
turn, exactly. As soon as you turn the heat on, it's going to be there. Or as soon as there's a temperature change, something happens within.
You hear
within
it in the morning,
material.
like my heating started to come on in the mornings now because it's cold. And you hear it like the.
Yeah. You'll hear the pipes tinging.
That's it. That's thermal expansion.
Yeah, that's it.
So obviously it's quite a traditional market, isn't it? I suppose. Well, some of the designs can be traditional, and I'd say the industry's quite traditional in that respect.
Yeah.
Obviously, there are things like bellows. You got things like the Sickler slide guides and anchors, and all these approved products. But is there anything else in the expansion industry which one you think could improve it? Is there something on the horizon like this new innovation that could help it, or have you got any? What are your thoughts on that? What's the future for expansion, or is it always going to be marking up drawings and dog legs here and anchors there?
Yeah, I think there'll always be a lot of can we eradicate thermal expansion with a change in direction? But I think I think London's our biggest market by far. I don't know whether you're the same, but London's our biggest market with basically risers.
Yeah.
I know there's one going up in Birmingham, like the biggest riser or biggest tower in London that's going up in the next couple of years. But London are already like way ahead of Birmingham in that, aren't they? So, so risers are our key market. We mark up the expansion in risers. We look at protecting the branches on risers, low temperature hot water risers in particular. So we're in the process of developing a product that it's an axial bellows, but it's also restrained as well, so it can take the weight of pipe above it and water weight above it to a degree, and also will stop any lateral movement.
So basically, it stops it going like this.
Yeah,
if
pretty
you like.
much. We
So
want
it's
to
a bit more rigid.
we want to try and stop it from squirming within pipework, within the risers, because obviously once the risers are in the riser cupboards and stuff, it's even more of a nightmare than on the floors to get at. So we want to try and we are in the process of developing. It's a tied off axial expansion joint, which will basically stop any lateral movement, and it will then reduce the loads on the guides. So when you mentioned the cyclic slide guides, they take a certain kilo rating. In risers in particularly, because of the weight of pipework that's in the vertical, that can be quite high. There only has to be a slight misalignment, and that can be a really high load. So we're coming up with something that will eradicate that. So watch this space on that one. That should be good. As long as we can. What we want to try and do is, because we know that riser cabinets can be very tight for space. So it's just a case of making it as compact as possible. That's definitely going to be eradicate. Try and keep your anchor forces and pressure on your guides as low as possible, and that makes it a lot easier to control your expansion joints.
And I suppose what's a good way of innovating is to keep the whole design solution would you say, as compact as possible? Is that always preferred? As short a route as possible, for example, rather than putting in big loops? Is that the preferred?
If you can put, normally you have to look at it in different. Say, are you looking at a 15mm half-inch steel 15mm copper pipework, or are you looking at 8-inch?
So that's the difference, really, isn't it?
You can easily put a loop, and it's a lot smaller putting a loop in a 15mm half-inch steel copper pipework. But if you're trying to tell a contractor to put a loop in an 8-inch,
you need a lot of space.
Lot of space. Takes some supporting as well.
Okay.
So it all depends what size, what weights and stuff you're looking at. But it can be. Normally you want to try and, like we mentioned before, we look. It's strange enough. We sell expansion joints and we stock a lot of expansion joints like that, like many people do. But it's actually the anchors that we look at first within a system. It's anchoring. Where can we anchor to control that movement?
Into that bellow. Into
the bellow, exactly. So so look at the anchor points, and then do we need to add bellows after that? But like risers are going to become bigger and bigger for us. As obviously space becomes a premium. So we have to go up. And we already do a lot of risers, I'm sure. I'm sure you see a lot of riser blocks.
There's more and more. There's quite a few big ones going up in Brum now. London's definitely riser capital, isn't it? But okay. Well,
what about modules, riser modules? Do you look at from yourself? Do you look at a riser module?
We do. We do. We have done riser module.
I think they'll become bigger and bigger. So
but I think on right. So would you actually a good point talking about risers? Is there a certain point? Because we did a job last year. I think it was 4 stories, and I don't think expansion was taken into account for that. I don't think we did, because we wasn't told any forces to design to.
No.
Is that correct? Would you say up to a certain amount of floors you don't necessarily?
4's probably where you need to start looking at it.
Okay.
But you'll probably have your main support that's holding up the riser, maybe on ground floor, floor 1. So therefore you've only got 3 stories above that, and then the 4 stories is your max.
The minimum.
Minimum,
without considering expansion.
That's it. And then anything above that, we would look to control the movement within that riser system. Firstly by anchoring, but then with anchoring, you're then holding up you're then taking on the responsibility of holding up that whole riser.
Of course.
So 60, 70, 80 meters up in the air. That's a big force that's on those bottom anchors.
But other than that, we have done some risers, not to the scale of 20 odd stories or whatever. But I think it's only going to be a matter of time. Particularly, we've done corridor modules where I think expansion's been. I think there was a job down at Deutsche Bank. I think you guys were involved with. Was it you?
Deutsche Bank. No, I don't think it was.
Oh no! Sorry, it wasn't you.
It definitely wasn't me. Anyway.
No, it was another. But there was basically we'd done the design of the brackets, and then the expansion company then worked with us to make sure that our brackets were sufficient.
Well, exactly.
And I think that's key as well. It's we'll say to the principal TM&E contractor, like, when we're doing your bracket design, you know, we will liaise with who's your thermal expansion, who you're speaking to. We'll liaise with you and get all the information to make sure, you know, try and take that stress away from them.
Yeah, exactly.
We might as well be because we're not benefiting from.
We're already doing our job for us, because if you come to us after you liaise with those, you're doing half. All we have to do is tell you where to put the bellows, or not.
Yeah.
If the case may be, because you already find out where the fixed points are, where the centre lines are, what the centre lines are, where the fixed point is, how the pipe runs going. You're already doing all that. So if there's just a simple case of putting in some bellows.
Mm-hmm.
The hard work for us is already done. It's just a case of saying to you guys, just put it there. Or move this fixed point bracket 10 metres in, and then let the expansion go on the corners, and it would be a lot. You know, it's a lot smoother process that way.
Yeah, of course.
Yeah, from our point of view, that'd be a lot easier, rather than dealing direct with whoever you know, with the main contractor, then coming back to you. It's like
it's a bit fragmented, isn't it? That's when you lose a bit of control and where communication comes into it.
Yeah, definitely.
All right, well, Dan, I think we've covered a few points there. I think I've learnt a bit as well. But yeah, no, I really appreciate you coming down today, mate. And good to see you again.
Yeah, definitely.
And see you soon, pal.
Yeah, definitely, mate. Definitely.